So let's continue with concavity, convexity, and the second derivative. So the second derivative of a function may also be used to determine the general shape of its graph on selected intervals. So when we look at here, if the direction of the function is downward and it is under the tangent line, as you can see here, we called it as concavity. So this is a concave function and its second derivative is less than 0. Okay, so when we look at here, we have, if the direction of the function, as you can see here, is upward and it is above the tangent line, we called it as convexity, and this is a convex function and its second derivative is greater than 0. Let's look at this example. Here we have, determine the concavity and convexity of f of x is equal to x to the power of 3 minus 6x squared minus 12x plus 2. So when you see these words, concavity and convexity, you know that you should take the second derivative of this function. Okay, so let's do that. First we need to take the first derivative. So the first derivative of f of x is equal to 3x squared minus 12x minus 12. And then we will take the second derivative of f of x, which is equal to, it is 6x minus 12, right? Okay, now we will find the value that makes this derivative equal to 0. So we will make this equal to 0, and from here 6x is equal to 12 and x is equal to 2. So this 2 is our critical point. Okay, also here we will draw our table again. So let's do that. 2 is our critical point. Okay, so here our second derivative of f of x, and it will start with plus sign because it is plus, the sign of x is plus, and plus minus, right? So here actually there is something different. That is, when you see this minus sign, it means that in this range our function is concave downward, something like this. Okay, so when you see this plus sign, it means that a function in this range, a function is concave upward, or we can say it's a convex function. So this is minus infinity and this is plus infinity. So we can say that between minus infinity and 2, our function is concave downward. Okay, and between 2 plus infinity, our function is concave upward, or in other words, this is convex. Our function is a convex function. So these are the range. So don't forget, after taking the second derivative, we found our critical point, and after that we put its signs, and then when it is negative sign, it means that our function is concave downward, and when it is plus sign, it means that our function is a concave, our function direction is a concave upward. Let's continue with inflection points. So if a function changes from concave upward to concave downward, or vice versa, around a point, it is called a point of inflection of the function. Like we did on the previous example, we made the second derivative equal to 0, right? And then we found 2 as our inflection point. At that point, the function changes its direction. For example, on this graph, till x0, the function is concave, right? And after this point, it changes its direction and becomes a convex function, as you can see. So here, this x0 is the inflection point. There can be more than one inflection points, and if the graph of f of x has a point of inflection, then the second derivative of f of x is equal to 0. In this example, we have, if there is an inflection point for f of x is equal to x cubed plus 2mx squared plus plus 3x plus 1 at the point when x is equal to minus 2, find the ordinate of this point. So when you see also this inflection point, you know that you should take the second derivative. Okay, so let's do that. The first derivative of f of x is equal to, it is 3x squared plus, this is 6mx, this will be mx, right? mx plus 3x. So from here we will get plus m plus 3. Okay, so after that we will take the second derivative, which is equal to, this is 6x, and this is, here we have plus 6m. So I know that when I make this equal to 0, okay, when I make this equal to 0, I will be able to find our my inflection point. So it is also given here, when x is equal to minus 2, it says that when x is equal to minus 2, this is we have our inflection point. So it means that when I put here minus 2, this equation will actually give us the right answer. So when I put minus 2 here, we will get minus 12 plus 6m, which is equal to 0, right? So here, when I put this minus 12 to other side, it's plus 12, which is equal to 6m, and m is equal to 2. So usually what we do, we know the value of m, right? We usually find the value of x, but here they give us the value of x, and now we are able to find the value of m. Okay, now since we know the value of m, let's rewrite our function here. So our function would be now f of x is equal to, it is x to the power of 3 plus it's 2, so it's 6x squared plus, this is 2, it's 5x plus 1. So what was the question? Find the ordinate of this point. So it's now very easy. Instead of x, I will put minus 2. So f of minus 2 is equal to, this is minus 8. This is 4 times 6, it's plus 24. This is minus 10 plus 1, which is equal to, this is 24 minus 10, it's 14, minus 6, it is 6 plus 1, it is 7. Okay, so this, it means that let's say this is our graph. So when x is equal to minus 2, okay, our y is equal to 7. So this means that at this point our function changes its direction. Okay, if it goes like this, then it goes like this. You see, so this information gives us this. So this is very important for you to understand. Don't forget, when you see this inflection point, you will take the second derivative and you will make this equal to 0, and then you will be able to find the solution for your question. Now let's continue with this example. Here we have f of x is equal to x plus 2 to the power of 4. So let's find its inflection point. So when we find inflection point, we will take its second derivative, right? So let's do that. The first derivative of f of x is equal to, it's 4 times x plus 2 to the power of 3. So the second derivative of f of x is equal to, I put this 3 here, it's 12 times x plus 2 to the power of 2. Now I will make this equal to 0, right? So here, since there is a second power here, it means it has a double root. Okay, so here, which value makes this equal to 0? It is minus 2, right? So here minus 2 is a double root. Okay, so let's draw our table. So minus 2, here we have x, so the second derivative of f of x. Okay, so when you have a double root, sign will continue as it is. We said it before. So since its sign is positive in the function, we will put positive, and then it is again positive. Okay, don't forget it. When you have a double root, your sign will continue as it is. Okay, if it starts positive, it will continue as positive. So here we have positive, which means the function here is concave upward, and here also it is concave upward. It's also concave function. So which means there is no inflection point here. Why? Because the function is always increasing, right? Its direction has never changed. In order to have an inflection point, your function directions, the direction of your function should change. So here, as you can see, it doesn't change. That's why we can tell that there is no inflection point here.